Okay, we're going to get started with a review for quiz 4.2 by going over yesterday's homework worksheet with practice quiz 4.2. First of all, I'd like you to take note of the three graphs over to the right. The first one, the left-tailed test, we're testing to see if something is in this shaded, unshaded portion to the left of the blue dot. If we're doing a right-tailed test, we're trying to find the area to the right of the red dot, and if we're doing a two-tailed test, we're going to find the total area between the area to the left of the blue dot and to the right of the red dot. So it's everything that's not shaded in green in each of the three graphs. So getting started with problem number 1, we have a z-score equal to negative 1.333, and we're doing a left-tailed test. So we select the function norm.s.dist, and as a result of selecting that function, just move the function builder, formula builder up a little bit. The z-score is entered as negative 1.333, and cumulative is true, and I just type a 1 for true, and we get that p-value is approximately 9%. For problem number 2, we're going to basically do the same thing, but because it's a right-tailed test and the area under the curve is equal to 1, we want to go to the right of that vertical line, so therefore we're going to do 1 minus. So we're going to start by saying equals 1 minus, and then we'll select the norm.s.dist function, and entering the z-score. We have z-score is 2.2, and the cumulative is again true, so we have that answer of approximately 1.4%. For a two-tailed test, what we have to do is find either the area to the left of the blue dot or the area to the right of the red dot. Because the z-score that's given here is negative, we'll be finding the area to the left of the blue dot by selecting norm.s.dist, and the z-score is negative 1.75, and cumulative is again true. So that area, it represents approximately 4% of the area under the curve, but because it's a two-tailed test, we have to double that for the p-value, so we say equals 2 times cell E6, and we get approximately 8%. So now I'm going to copy those three values, and I'm going to paste those values. So I'm going to do paste value. Now we can answer the second part of the question, which is actually 3 parts to each one. If the value for alpha is equal to 10%, the column on the left down below here. If the value is 10% for alpha, the rejection region is anything that anytime the p-value is less than alpha, so 9% or 9 point something percent is less than 10%, so on problem number 1, for a 10% level of significance, we reject the null hypothesis. Anytime the p-value is not less than the value for alpha, we fail to reject. So when the value for alpha is 5% and the p-value is 9%, we fail to reject, and the same for 1%. 9% is not less than 1%, so we fail to reject the null hypothesis there. And the same for the other two problems. For problem number 2, because the percentage is approximately 1.4%, we reject the null hypothesis when it's a 10% value for alpha. We also reject the null hypothesis when it's 5%, but we fail to reject the null hypothesis when it's 1%, because 1.4% is not less than 1%. And for the last one, because it was a two-tailed test, the p-value is 8%, not the 4% that we did over to the side. So we reject the null hypothesis for a 10% level of significance, and we fail to reject for both 5% and 1%. On the next page, we have 3 word problems. The first one is a right-tailed test, the second one is a left-tailed test, and the third one being a two-tailed test. So I have the answers filled in here, but I'll show you how I came up with all of this. For problem number 4, the employees at company A claim the mean salary at their company is more than $75,000 per year, and you select 30 employees at random and find the mean salary is $76,500 with a standard deviation of $4,000. Is there enough evidence to support this claim at a 1%, 5%, and 10% level of significance? So the first thing I did was I stated the null hypothesis over to the right here, and we have the null hypothesis is going to have an equal sign in it, so that is less than or equal to 75,000. The alternative hypothesis, which also happens to represent the claim in this case, is that the mean salary is greater than 75,000. So we find a corresponding p-value, but I already have the work completed, but I'll show you how we did this. Because it's a right-tailed test, we start out with equals, I'll just do it again down below, equals 1 minus. And now we're going to use the norm.dist function, and by selecting the norm.dist function, we're going to state the value for x, in this case is 76,500. The value for the mean is the 75,000 as stated in the problem. The standard deviation, however, is going to be equal to the 4,000 as stated in the sample divided by the square root of the sample size. So it's the square root of 30 employees. And we have cumulative is also equal to true. So we have an answer of approximately 2%. As you can see, same as what I had before. So if the answer is approximately 2%, and let's go down to part C. Is there enough evidence to support the claim at a 10% level of significance? And because the value for P, 2%, is less than the 10% value for alpha, we reject the null hypothesis. So we're rejecting the fact that the mean is less than or equal to 75,000. Therefore, that means we're kind of accepting the alternative hypothesis, and therefore we are supporting the claim. So the answer to part C is reject the null hypothesis, meaning we are supporting the claim that the mean is probably greater than 75,000. Because 2% is also less than 5%, we reject the null hypothesis for a value for alpha equal to 0.05, and therefore we support the claim as well. But when the level of significance is 1%, or the value for alpha is 0.01, we fail to reject the null hypothesis. Therefore, we do not support the claim. We simply state, so it would be better if we stated the answer as not enough evidence to support the claim. Okay, for problem number 5, we have a left-tailed test because for the alternative hypothesis we have a less than symbol, so that indicates that it's going to be a left-tailed test. The problem states that a local coffee shop claims special blend coffee contains less than 150 milligrams of caffeine per cup. You are hired by an independent agency to test this claim. your sample of or your sample of 50 cups of coffee has a mean caffeine content of 147.5 milligrams with a standard deviation of 13.5 milligrams. So same as the previous problem, we find the p-value, but because it's a left tail test, we don't do the 1 minus anymore. We just do a norm.dis function with the value for x equal to 147.5 as stated in the problem. The mean is 150. The standard deviation or standard error is 13.5 divided by the square root of 50 because we had a sample size of 50, and true, meaning the entire shaded area to the left of that vertical line. So again, I like to start with part C, 10% level of significance, because 9% or 9.5% is slightly less than 10%, but it is less than 10%. We reject the null hypothesis, which is greater than or equal to 150, and therefore we support the claim that it is less than 150. When the level of significance changes to 5% or 1%, we fail to reject the null hypothesis, and therefore we do not have enough evidence to support the claim. And it's the same for both 1% and 5% because the p-value was 9.5% approximately. For problem number 6, we have a two-tailed test. The nutritionist claims the typical U.S. adult consumes 10 pounds of fish per year. A random survey of 50 U.S. adults has a mean of 9.25 pounds with a standard deviation of 3 pounds. So now to find the p-value, we have to slide over to the right a little bit here. To find the p-value, which is approximately 7.7%, we first of all have to find the area in one of the two tails. So as you can see here, I've put in a norm.dis function dealing with 9.25. This is for the left tail. 9.25 is the value for x, and 10 is the value for the mean. 3 divided by the square root of 50 is the standard deviation as you put it into the function builder, or the standard error, and the 1 represents true. So that's the area in one tail. We doubled that, as you can see, in cell N19, and we get 7.7% approximately. Now, the null hypothesis is that it is equal to 10. The alternative hypothesis is that it's not equal to 10. The claim in this case is the null hypothesis that it is equal to 10. So for part C, once again, starting there, with a 10% level of significance, we reject the null hypothesis because 7.7% is less than 10%. So therefore, we do not support the claim. There's not enough evidence to support the null hypothesis. When the level of significance is 5% or 1%, because the value for the p-value is greater than the value for alpha, then we fail to reject the null hypothesis, and therefore we are supporting the claim. Hope all of this helps. Take care.